Welcome to my speaking notes. In this episode, I'm going to show you how to solve equations involving complex numbers. The first question says solve for x and y given that 1 over x plus iy plus 1 over 1 plus 3i is equal to 1. The first idea is to make the left hand side a single equation. By doing so, we find the lowest common denominator, which is x plus iy multiplied by 1 plus 3i. Now we divide x plus iy into the denominator. We remain with 1 plus 3i multiplied by 1. We do the same in the second sum, which is equal to 1. Now we remove the fraction from the left hand side by multiplying throughout by x plus iy 1 plus 3i. So when we do that, here we remain with what is in the numerator, which is 1 plus 3i plus x plus iy. Now 1 multiplied by what is in the denominator, we have x plus iy, then 1 plus 3i. Now I expand what is on the right hand side. So x on 1 plus 3i and iy on 1 plus 3i. So this is just x plus 3xi plus yi. Now this is minus y because this is I multiplied by I, which is negative 1. Then y multiplied by 3, which is 3y. Now observe that x is common on the left and the right hand side, so that is a 0. Then iy and iy cancels. So on the left hand side, I remain with 1 plus 3i, which is equal to, on the right hand side, I remain with 3xi minus 3y, which I can rewrite as negative 3y plus 3xi. Now, this is a complex number. Observe that on the left-hand side, I have 1 plus 3i, which is equal to negative 3y plus 3xy. Now, these numbers can only be equal if the real part, which is 1, is equal to negative 3y. So, which is negative 3y is equal to 1. Divide throughout by negative 3 so that y is negative 1 over 3. Also, 3i should be equal to 3xi. So the I and the I cancel, so that 3x is equal to 3. Divide throughout by 3 so that x is equal to 1. In the next problem, we have x over 1 plus I minus 1 over 2 minus I is equal to 1 minus 5i over 3 minus 2i. Now, the idea that I'm going to use is very simple. We are going to simplify each fraction, then combine the results. What I mean is this. We get the first expression, which is x over 1 plus I. To simplify this, we multiply both the numerator and the denominator by the conjugate of the denominator. The purpose is very simple. We want to remove a complex part of the denominator. So the conjugate of 1 plus I is equal to 1 minus I. We negate the complex part. So I multiply by 1 minus I and multiply by 1 minus I. So in the numerator, I have x multiplied by 1 minus I. Now in the denominator, this is just the difference of two squares. So we have 1 plus I multiplied by 1 minus I. So by the difference of two squares, we have 1 minus I squared. So this is just 1 plus 1, which is equal to 2. Why? Because I squared is negative 1. So negative 1 multiplied by negative is positive. So we have 2. So in the denominator, we put a 2. Okay. Now we are going to simplify the middle part. I leave the sign. To do that, I again multiply by the conjugate. So the conjugate of 2 minus I is 2 plus I. I do the same in the numerator. So the numerator just remains like that, y multiplied by 2 plus I. Now in the denominator again, we have 2 minus I multiplied by 2 plus I. Again, this is the difference of two squares. So this is just two squares, 2 squared. Now, this I squared is -1, but with the negative that is in the middle, it will just be plus 1, which is equal to 5. So I divide it by 5. Next, we simplify what is on the right-hand side of the equality, which is 1 over 5I divided by 3 minus 2I. Multiply by the conjugate of the denominator, which is 3 plus 2I. I do the same in the numerator and the denominator. Now we divide throughout by 13, which is 1 minus I. Now remember, the expression is the sum of these terms. So I get the first one, 1 minus 2 is equal to 3. So when I do that, I have x on 1 minus I over 2 minus y on 2 plus I over 5. Now this is equal to 1 minus I. 1 minus I is our 3. Now I do not want any fraction. I want to solve for x. So the least common multiple of 2 and 5 is 10. So I multiply the whole equation by 10. If I do so, this is just 2 into 10 is 5. So I multiply this expression by 5. So that is 5x on 1 minus I minus, again, 5 into 10 is 2. So I multiply that by 2. So that is 2y on 2 plus I is equal to, so 1 minus I multiplied by 10, which is 10 minus 10I. Next, I expand. So this is just 5I minus, so this is just 5x minus 5xi minus 4y, and then minus 2iy. The minus is coming from the minus here, and the right hand side remains the same. Now I can group like terms. So those variables that do not have I in it, which is 5x minus 4y in that variable, and this is minus, I factor out negative I, which is and remain with 5x plus 2y, which is called 10 minus 10I. Now we are solving for x. So what we are going to do, we get the real part. This is 5x minus 4y is equal to 10. So I equate the part that does not have I to the part that does not have I on the left and on the right, so that I have 5x minus 4y is equal to 10. Now the part that has I is all this part, right? So I just write it, which is equal to negative 10I. So the i's go away. So I just remain with that equation. Okay. Now to this equation, we multiply throughout by -1 so that I remain with a positive equation. Now these are two equations, so I can name this equation 1 and this is equation 2. So I solve equation 1 and 2 simultaneously. We can solve these two equations by using elimination method. So we eliminate x by subtracting the two equations. So 5x minus 5x is 0, and negative 4y minus 2y is negative 6y. Now this is 10 minus 10, which is 0. So negative 6y is equal to 0 if and only if y is equal to 0. Now I can try to be lazy by substituting y into the original equation, right? Y in 1. So y is 0, so this thing is 0. So I remain with 5x is equal to 10. Divide throughout by 5 so that x is equal to 2. Our equation yields x is equal to 2 and y is equal to 0. So these are the only two numbers. So these are the only two numbers that satisfy our equation. All right, so we end here. Thank you for watching. Please subscribe and follow so that you can receive notification whenever we upload new material.